All right, so today we're going to start chapter 2. Okay, and again, we don't really go in order, but we are going to do the first couple sections in chapter 2, but then we're going to skip ahead to a different chapter, and then we might come back to chapter 2 later on. So the first section we're going to look at is called angles and their measures. So the first thing we're going to do is basically talk about what an angle is, or what an angle is made up of, and then we're going to talk about the two ways we can measure angles in trig. You're probably familiar with using degrees to measure an angle, but there's another way we can use too, right? And we'll talk about what that is. All right, so before I even talk about an angle, I'm going to talk about what makes up an angle, and that's a ray. Okay, so a ray is basically a portion of a line. It has a starting point. We call that point the vertex. And I say it's a portion of a line because it only goes in one direction. Okay, so you think of it like turning on like a flashlight. You turn it on, it's a beam, it goes in one direction. And the starting point, again, that's called the vertex. Now, if you take two rays and put them together, okay, so they have a common vertex, common starting point, that's how you create an angle. Okay, so I've got two rays, separate like that. They're just two rays. They're nothing special. But once I make it so they have a common starting point, now I've created an angle. And those two rays, we call those the sides of the angle. Okay, and each side has a special name. Does anybody know what you call the two sides of an angle? One side is a certain name, the other side is a different name. Okay, so the side right here, this is called the initial side. And this is the terminal side. And the way you figure out which side is initial and which side is terminal is basically you go in between the rays. Okay, don't go outside. Stay on the inside. And you go in a counterclockwise direction. The side that you start at, that's the initial. The side that you end at, that's the terminal. So stay between the rays and go in a counterclockwise direction. Right, and I got another picture right here. Pretty much the same thing. The way I've drawn the angle on the bottom, that's a better way to draw it. And we'll talk about the placement of the initial side and how you do it versus just kind of drawing an angle like that. That one's a little rotated from what it should be if we're going to draw it in what's called a standard position. So I'll explain what that is in a little bit. But any question on initial side, terminal side? Okay, so those are the two sides of your angle. Now, we can measure an angle in two directions. Okay? I'm going to show you the two different ways you can measure an angle. And the reason we have two different ways of measuring an angle is because it's going to tie in with basically whether you're measuring it clockwise or counterclockwise. All right, so let's take a look at this. So in this diagram, I can't move the initial side. Okay? It stays right there the whole time. But I can move the terminal side, okay, wherever I want. If you're measuring an angle and you're going in a counterclockwise direction, you get a positive angle. So if you're measuring an angle and you rotate from the initial to terminal side in a counterclockwise direction, that's measuring a positive angle. And I'll bring that program back up in a second, but you might have noticed there were two numbers that were measuring the angle. Again, I'm going to put this slide back up in a second. But does anybody know why there's two numbers that are measuring this angle? Does anybody know what either one of those numbers are? One's in radians and one's in degrees. So that's what we're going to talk more about later on. Specifically, how do you convert between the two? All right. So counterclockwise is a positive angle. What do you think happens if you go clockwise? It's going to be negative. Okay. So that's measuring a negative angle. Okay, so if the rotation is clockwise, it's a negative angle. So what that basically means is sometimes you have more than one way to write the same angle. Okay, you can go different directions to get to the same spot. Right, so if I go back to that picture, if I had negative 90, okay, just focus on where the kind of that red and black circle is. Okay? It's on the negative part of the y-axis. If I go like this, it's still on the negative part of the y-axis. Right? So there's two different ways to get to exactly the same spot. One was clockwise, the other was counterclockwise. In general, if we can do calculations with a positive number, that's easier than working with a negative number. So anything that we do in trig, you could use 270, or you could use negative 90, and you're going to get all the same answers for the stuff that we're going to do. But most of the time, we try to stick with the positive. Okay, any questions on that? Don't worry so much about this number on the bottom. We'll get to that. All right, so I told you that when we sketch an angle, a lot of times we like to draw it a certain way. Every angle that I just showed you in this program was drawn in what's called standard position. Two things have to happen for an angle to be in standard position. One is the vertex of the angle has to be at the origin. In this program, it always is. I can't move the vertex of the angle from the origin. And the second thing that has to happen is you want the initial side on the positive x-axis. So that's a picture of an angle that's in standard position. It meets both criteria. How about if I went like this? Actually, I didn't want to break it apart. Is that angle in standard position? What do you think, Cole? No. The positive, I tried to make it so the initial side is on the positive x-axis, but now the vertex isn't at the origin. Okay. How about if I did something like this? Would that be standard position? Nope. What's wrong with it now, Katie?
The initial side isn't on the x-axis.
Right, the initial side's not on the x-axis. The vertex is at the origin, but it doesn't meet the other criteria. Okay. So for standard position, that's what you're looking for. Any questions on what it means to draw an angle in standard position? Okay, so that's kind of just the background stuff I'm going to go through about drawing angles. The next thing we're going to talk about is radians and then how we convert between degrees and radians. So kind of the big picture idea is to figure out that question mark. Okay, I'm going to assume most people knew in one revolution that's 360 degrees. But the question is, how many radians in 360 degrees? Or how many radians in one revolution? Same question. So by having this fact, okay, that's kind of a starting fact. You can use that fact that I just underlined in red to convert between revolutions and degrees very easily. Let's say you wanted to know how many revolutions is 510 degrees. Well, as long as you know that 360 degrees is one revolution, you can put 510 degrees is how many revolutions? And then we could just cross multiply and solve. But the whole key to doing this is you already knew this fact. You already knew that in 360 degrees there's one revolution. Without that, you can't do anything. So it's the same idea here. We need that fact that's going to allow us to convert between degrees and radians, but right now we don't have anything to start with. So eventually we're going to figure out that question mark. And then once we know the question mark, we could easily set up something like this and convert between degrees and radians. So any questions on what we're going to try to figure out? Okay, but before I even tell you or lead you how to figure out how many degrees, how many radians in 360 degrees, I'm going to describe what a radian is. Okay, and I'm going to do it visually. Okay, and I'm going to start with that circle. So what I've done is drawn a circle. Inside the circle, I put an angle. Those are the two black rays. And I labeled each black ray with an R. What does that R stand for?
Radius.
Radius. And if you look at the word radius and radian, they both kind of start out, well, they do start out with the same four letters. And there is a connection between the two, and that's what I'm about to show you. So we've put that angle inside the circle. The initial side comes along the bottom, hits the edge of the circle right there. The terminal side comes out from the center, hits the edge of the circle right there. Does anybody know what that shape in red is, connecting those two dots? It's part of a circle, but does anyone know what you call that? Just part of a circle? That's an arc. Okay, that's an arc. So I'm going to look at something having to do with this arc in red. And it turns out that if the length of this arc came out to exactly the same length as the radius, then you just drew a picture of a radian. Exactly one radian. All right, so if you took a ruler and you measured that ray in black and say it came out 5 inches, and then you took a piece of string and put it along that arc in red and you measured it, and that came out to 5 inches as well, then what that would mean is you have a picture of exactly one radian. Now, if I put any angle I want inside a circle, do you think that the length of the arc will always come out the same as the radius?
No.
No. I could do something like, let's just take a circle, could draw an angle like that. Now, in this case, I would say that this arc is much shorter than that radius. What that means is this angle is smaller than 1 radian. I could also draw it so the arc is bigger. But the point is, if it comes out exactly the same as the radius, you have a picture of 1 radian. So any question on that idea, what a radian looks like? It still doesn't answer anything numeric. It doesn't tell you, oh, 1 radian is this many degrees. It doesn't tell you that. It just gives you kind of something to visualize in your head for a radian. All right. So in order to figure out that question mark, I have to give you something to work with. So I'm going to give you this fact. Okay, you just have to trust me that that fact is true. And it says an angle's measurement in radians is numerically equal, or is the same, as the length of the corresponding arc on a unit circle. So before we can kind of piece that together, the first thing we just want to make sure of is what's a unit circle? A unit circle is a circle with a certain radius. Does anybody know what the radius is in a unit circle? 1. Okay, so it's circle with radius 1. That's all. Okay, so it's a circle with a radius of 1. Any question on just the definition of what a unit circle is? And then we're going to kind of fit that into what's up here. All right. So kind of just breaking it down and highlighting the important part. The angle is equal to the arc. That's the important thing in that sentence. The angle is equal to the arc. So in other words, if you drew a unit circle, so you drew a circle with, that was 1 unit with the radius. Okay, 1 unit radius, 1 foot, 1 inch, it doesn't matter, 1 unit. And then you were to measure the size of your arc and the size of your angle, they would always come out exactly the same. So if you had, say, this circle, here's an angle. Let's say that this was 1 foot, okay, just to make it a unit circle. And I said to you, all right, I want half of you to measure this. Okay, so I give you time and half the class measures that. And then I say, all right, I want the other half of you to take a protractor and measure that angle. You would all get the same answer. If it's a unit circle, whether you measure the length of the arc or you measure the size of an angle with like a protractor, you're each going to get the same answers. Okay? That only happens if your circle has a radius of 1. Okay, so that's an important connection. Arc size and angle size are exactly the same on a unit circle. So the only thing we need to figure out is a connection between the two numerically. Some kind of numbers to fill in here. So can anybody think, I want to think of an arc. I want to think of an arc that's so big, it takes up the entire circle. So it's not just a part of a circle or half a circle, it's the whole circle. Okay, that's still technically an arc, but it has a special name. Does anybody remember what you call an arc that makes a complete circle? It's the whole circle, not just a part of it. It's what? Not sure?
Is the circumference?
It is. It's called a circumference. A circumference is an arc. But it's a special arc that takes up the entire circle. All right? So I need to ask two things. First thing I need to know is how many degrees to go all the way around a circle? 360. Right? So we know something about an angle in degrees. What we need is it in radians. Well, if you can tell me what the circumference of this circle is, that's the answer to the question mark. That's all I need to know, is the circumference of that circle. Why the circumference? Because the circumference is exactly the same as the angle. The circumference is equal to the angle. And if you do it that way, you're automatically going to be in radians. Okay, so what's the formula for the circumference of a circle? Remember that? Formula for circumference of a circle. Well, Kate, remember? Close. A little too much, you said. Yeah, you need a little more.
2 pi r.
2 pi r. That's the formula for the circumference
And then,
of a circle.
doesn't it happen where it's like 2 pi r h to the height, like trying to find the height of?
That's for volume. Yep, the volume of a cylinder. Actually, no. The volume of a cylinder is 2 pi r squared h, I think. I have to double check. My volume and area formulas are a little rusty. Now, there's the formula for the circumference. What's the radius of this circle if it's a unit circle? About Joe?
I'm not really sure.
Well, it's a unit circle. So what did we say earlier that a unit circle has a radius?
So, radius of 1.
Has a radius of 1. So the circumference of this circle, that's supposed to be 2 pi times 1. Let me try writing it over here. So what does that mean the circumference is? Oh, James? Just 2 pi. And now because that's a unit circle, that 2 pi is a measurement of the arc, the circumference. But what is that the same as? That 2 pi is the measurement of the arc, but it's also equal to the measurement of the measurement of the what? The angle. So that means in 360 degrees, there are 2 pi radians. Because the circumference and the measurement of the angle come out exactly the same. If we didn't have this fact, we would be stuck. We wouldn't be able to figure this out. Okay, but using that fact, we can figure it out. So now we know 360 degrees. In 360 degrees, there's 2 pi radians. Now we've got a connection between degrees and radians. But we're going to make it a little simpler to work with. Anybody tell me what I could divide both sides by to make the numbers a little smaller? But it'll be equivalent to what I have there. Yeah, I could divide each side by 2 and say that in 180 degrees, there's pi radians. Now that's the fact we're going to use, but that's still not the simplest way to say it. Okay? If I gave you a connection between two other units besides degrees and radians, I wouldn't say it like that. Okay, let me give you some examples and tell me what they all have in common. Okay, in 12 inches, there's 1 foot. 60 minutes is 1 hour. 24 hours is 1 day. 3 feet is 1 yard. All those things I just gave you, they all had something in common that this doesn't. What did they all have in common? They all had a 1 in there. Okay, when you want to tell somebody how to convert from one unit to another unit, usually you give them a conversion with a 1 in it. That makes it easy. If I wanted you to convert between feet and inches, I wouldn't say in 5 feet there's 60 inches. There's a simpler way to say that. 1 foot, 12 inches. Okay, so same idea here. I want to get a 1. And the first way that I'm going to do it is let's get a 1 on this side. So if I wanted to turn that side into a 1, what would I have to divide both sides by? I'm going to divide each side by 180. 180 degrees divided by 180 leaves me with 1, and I still have the degree symbol from the top. 1 degree equals pi over 180 radians. Now, let's say I didn't want to know 1 degree. I wanted to know 2 degrees. What could I multiply each side by to change that 1 into a 2? Just multiply it by 2. Okay? Leave what you have in your notes right now. I'm just going to show you something, but I'm going to put that back. So I can multiply by 2, multiply by 2. Now I have a formula for 2 degrees. Okay. What if I wanted to know 5 degrees? Well, I'd multiply by 5, multiply by 5. So this is the whole key right here. If you want to convert degrees to radians, all you have to do is take the angle you want to convert, a 5, a 7, whatever it is, multiply it by pi, and divide it by 180. Those are the 2 steps. So I'm just going to put this back the way it was. And those are your 2 steps. To change a degree to a radian, multiply by pi, divide by 180. And usually we don't write pi as 3.14. We just write the pi symbol. Okay, we don't round anything off unless they directions say to. Okay, so those are the 2 steps to change degrees to radians. There's also 2 steps to change radians to degrees. Okay, I'm going to go back to that equation I had. I want to change it again so there's a 1 in it, but I already did it so that there's a 1 on the left. This time I want to get a 1 on the right. So Joe, what would I divide each side by to get a 1 on the right?
Divide by pi.
Yeah. Divide by pi. Divide by pi. Pi divided by pi is 1. We still have RAD. And then on the other side, 180 degrees over pi. So now you have a formula that tells you 1 radian is that many degrees. So if you wanted to know, you could do that on your calculator. Do 180 degrees, divide by, and hit your pi button. And that'll tell you how many degrees in a radian, roughly. Cece, if I wanted to know for 2 radians what it equals, what would I have to do on both sides of that equation? Multiply by 2, multiply by 2, and then do it out. What if I wanted to know Allie for, say, 5 radians? I would just take that equation and multiply by 5. I would get 5 and then I would have to do that out. So this is the whole key. If you want to change a radian, okay, to a degree, you have to take what you want to change, multiply by 180, that's step 1. Step 2, divide by pi. So it's very similar to the other 2 steps, but it's multiply by 180, divide by pi. And I think those 2 steps are between degrees to radians and radians to degrees. They're very similar, so it's easy to mix them up. I'll show you how you can remember which way is which. Okay, so we'll practice changing between the 2. If they do not give you any specific direction, we leave pi. If they want us to round it, they'll say in the directions, round to 2 decimal places or 3 decimal places. Okay, but otherwise, we just leave the pi. All right, so let's start with 60 degrees. Anytime you want to convert between degrees and radians or radians and degrees, it's going to involve a pi, and it's going to involve a 180. You just have to remember which one goes on top and which one goes on the bottom. Okay, the trick, to remembering is when you think degrees, I want you to think the number 180, because that has a degree symbol on it. So when you think degrees, think 180. When you think radians, I want you to think pi. So just remember that in your head. Radians, think pi. Degrees, think 180. Just hang on to that for a second. All right, so now we want to convert 60 degrees to radians. When I'm done, I want this degree symbol to cancel out. So where in the fraction on the right would degrees have to go to cancel out the degrees on the 60? In the top or in the bottom? James? It would have to go in the bottom. Think of 60 as a fraction. If you want to cancel something out, it has to appear in the top and the bottom. And we want degrees to cancel out. Now, if you put degrees in the bottom, what was the number I just said to think of when you think degrees? 180. Yeah, 180. If degrees is on the bottom, the only other choice is radians for the top. And what number did I say to think of when you think radians? Pi. And now you just multiply straight across. If you want to reduce first, you can. 60 goes into itself once. How many times does 60 go into 180? 3. And now multiply. 1 times pi. You can put 1 pi or just pi. And then 1 times 3. And that's the answer, and that's how you leave it. Pi over 3 radians. Okay, any questions on that? The only thing you have to get used to is a lot of times when you write an angle in radians, they don't write RAD. If you want to put something in degrees, you have to put the little circle above the number. But in general, if we're talking about angles and they just wrote something like this on the paper, pi over 6, that's radians, even though it doesn't have RAD after it. Kind of think of the RAD as being invisible. Okay, so from now on, I'm not going to write RAD anymore. You just have to understand it's there. Unless they put a circle, then it's degrees. Okay, let's try 150. All right, so Joe, again, same directions. We're changing to radians. So where would degrees go to cancel out the degrees in the top?
On the bottom.
On the bottom. And the number you think of with degrees?
180.
Yep, there's your 180. And Jeff, the number you think of with radians?
1.
Not 1. So there's only two choices here. We have 180 and pi. Pi. So those are the only two numbers we're ever going to use. It's either going to be a pi over 180 or a 180 over pi when we go the other way. Okay, so degrees cancels. If you want, you can quickly reduce both by 10. Just cross off the zeros. How about 15 and 18? Ethan, what could I reduce both of those by?
3.
Yep. How many times does 3 go into 15?
5.
And 18?
6.
6. Okay, so Stephanie, could you tell me what my final answer would be?
5 pi over 6.
Yep. And I don't have to write RAD. Okay, we just assume that it's there. Okay. Any questions on that? All right. A negative angle would work the same way. We could do that one. Why don't you try that one? The only thing that's different about a negative angle is do the whole problem, and then when you're done, throw a negative in the front. That's the only thing that changes. Okay, so as I walked around it, things looked pretty good. Again, degrees on the bottom, 180, pi. In fact, this time I wanted you to get used to not seeing RAD anymore, okay, because if you wrote it, that's fine. You can continue to write it. It's just on a test, you probably won't see it. What number goes into both 45 and 180? And if you can, what's the biggest number you can think of? Yep. Yep, 9 goes into both. But there's actually one even bigger, but you could do 9 and then do it again. Yep. 45. Once. And how many times did that go into 180? 4. So you're left with negative 1 pi. Negative pi over 4. And that's it. That's your answer. Any question on that one? Mm-hmm.
If it's negative, would it stay on the top?
It doesn't really matter if you put the negative on the top, on the bottom, or put it right in the middle. I usually put it on the top to make it clear, because I think if you do something like this, sometimes it's a little confusing to me if that's part of the line or not part of the line, but if you put it in the top or the bottom, that makes it clear. I'm going to skip 90. If you want to check it on your own later, that one would be pi over 2. Let's try this one. And because it's kind of a weird angle, we're going to round to 2 decimal places. And when I say weird, I mean it's not a multiple of 30, and it's not a multiple of 45. So we still do it exactly the same way. Pi on top, 180 on the bottom. The only difference is it says round, so I'm actually going to type it in and round it off. Okay. When you type in pi, make sure you use your pi button. On the next one that we round off, I'll show you what happens if you don't. Okay, I'll show you how much it can throw off your answer. So we'll do 107 times pi. And I'm not even going to round that. I'm just going to take that whole thing and divide by 180. Okay, so I get about 1.87. And what's that again? 1.87 radians. Do I need to write down RAD? No. Okay, so that's converting degrees to radians, both as an exact answer. All these ones are exact, and as an approximate answer. That's the one with the decimal. Okay, so the last couple we'll do is just just converting the other way. We'll do some exact ones and then some ones where we round. For the first problem, I'll put RAD again, but after this, I'm going to erase it, so you get used to not seeing it. All right, so Casey, we've got radians in the top, and our goal when we're done is degrees, so we want radians to disappear. Where would you put it to make it disappear?
Put 180 on
Yeah, you put the 180 on the top, and on the bottom,
pi.
there's your pi. By putting the radians in the bottom, it's going to cancel radians in the top. Is there anything else there that cancels? Yeah, the pi's cancel. So radians cancels, pi's cancel, and all you're left with is 180 degrees divided by 6. What's 180 divided by 6? 30. 30 degrees. Do I need to put degrees? Yes, I do. If I leave it like that, I'm going to think you mean 30 radians. That's 30
Wait, so
degrees.
we wouldn't have to just write rad, right?
No, in fact, that's why in the future I'm going to start erasing RAD.
Okay, and the bottom one, so it's supposed to be there, just
I put it there just so you can see that radians in the bottom and radians in the top cancels. In the next problem, that's going to be invisible. So you just have to remember that it's there. So in your head, just remember, okay, 3 pi over 2, radians is in the top. So Jason, what would I multiply by to cancel out radians? We're going to go 180 over pi again. Now it's invisible this time. Radians cancels out. Okay, but I'm not going to write that down. Pi cancels out. And we can reduce 2 into 180. So the only thing we're left with is 3 times 90, and then put your degree symbol. Okay, so Michael, what do I get for that one? Perfect. Yep, 270 degrees. Any questions on that one? All right, that's just with a negative. I'm going to skip that one, but if you want to go through and try that one later, that would be negative 135. Try it and you'll see that's what you'll get. Okay, let's try another one where we want to round. And this time I'll show you what happens if you use the pi button versus 3.14. So round to 2 decimal places. Okay, same directions as way up above. Convert from radians to degrees. All right, so Brandon, what's going to go on top here? 180. What's my my label I want to put on that? Degrees. How about the bottom? Pi. What's my label on that? It's not nothing. It has a label, we don't write it. So it's radians, but we don't have to write it down. So think radians just canceled out, and now just multiply straight across. Okay, 3 times 180, that's 540. And I'm going to divide by pi. So using the pi button, I get 171.89. And that's degrees. Okay, if you don't use the pi button, let's say you use 3.14. Let me show you what happens. So 3 times 180, again, that would be 540. And divide by 3.14. So instead of 171.89, I get 0.97. Well, 0.89 and 0.97, it's not really that close, okay, depending on the accuracy you're looking for. Okay. On a test, if you had like 171.88, I mean, that's pretty close, but 97 versus 89 is too far off. So make sure you always use the pi button. Okay. So any questions on that? Okay, so that's how you convert between radians and degrees. So homework tonight is page 99. And it's 36 to 68 even. Okay, just the evens. Okay, and you've got a little over 15, well, a little under 20 minutes. Okay, so please use the time to get started. If you need to borrow a book, I've got some extras. If you want to work with somebody, that's fine too.